And I'm recording. There might be a little box that you have to select that says you don't mind. Okay, as we talked about last time, the notes for this section anyway, for any long section, were broken into 3 sections. So the first one was the function and sort of definition of function stuff. And then we did critical points and symmetry. That was part 2. And part 3 is the only part that is dark here. The others are grayed out. And you see that this is part 3, and it says here part 3 of 3. All right. So the little circle, does the little circle mean multiplication? I want to hear this loudly. I want to hear loudly.
No.
No, no, no. And it's okay to say something wrong in our class. It is absolutely fine. That little circle means composition. And it's the first thing that functions can do that numbers can't do. So we can multiply, divide, add, and subtract numbers. We can raise them to powers and reduce them, but we cannot compose them because there's nothing to put something into. Whereas with a function, if we have f composed with g of x, that is really just saying put g of x inside of f, and this is what we mean. So if we have f of x as 1 over 2 minus x, and say g of x, oh, let's make g of x a different color. So say we have g of x as 3x squared. Then f composed with g of x means that we are actually looking for f of g of x. So everywhere that there was an x in the formula for f, we're going to put the whole g of x. So let's see what that means. We've got 1 over 2 minus, and instead of x here, we're going to put 3x squared. And then to simplify it, all we have to do in this case is take away the parentheses. So we have 1 over 2 minus 3x squared. The wonderful thing about composition is that most of the time it is not commutative. It changes depending upon order. So if we have g of f of x that will be g of, and we're going to put f of x instead of x in all of the places where we had an x in the g formula. So we have 3 something squared, and instead of something, we're going to put 1 over 2 minus x. And I chose to do this example, or one of them with a square, because it's always fun to remember how to square a binomial. Bi meaning 2 nomial terms. So we've got, let's just do that part. Let's just find 1 over 2 minus x squared. Oh, thanks, Ben.
Yep.
How do you square a fraction, first of all?
I just use my calculator.
Nixo, hey ho. And that means no.
What was the
how,
question again?
how do you square a fraction?
Square root, I think.
So if we have, orange is feeling left out. If we have a over b squared, that is the same as a squared divided by b squared. So you just square the numerator and square the denominator. So here we've got 1 squared, which is
1.
yay. And then we've got 2 minus x squared. And that was the binomial to which I was alluding, because it's always fun to remember how to square a binomial. We're going to do it 2 ways. I want you to remember the pattern rather than all of the steps. So here is the pattern. If we have a plus b all squared, that is a squared plus twice ab plus b squared. And that's because if we have a plus b times a plus b, well, how do you FOIL this? How do you multiply out any 2 binomials?
FOIL.
How do you FOIL?
It would be
Oh yeah, a
times
a times a times b, and then b times a times b.
Okay, so a times a plus a times b, so a times b plus, and then what's next?
B times B.
Well, first b times a.
B times a, and then b times b.
Yes, good. Perfect. And we're looking at number multiplication. So is a times b and b times a, are those different or the same?
They're the same.
Excellent. So that's why we have a squared, we have 2 a plus a times b's, and we have a b squared. But this pattern is super handy, and we're just not going to have time to think about multiplying it out every time. So let's see. In this case, what is a and what is b? Because you notice I only used a plus sign here. So what is a in this binomial?
2.
Good. And b?
Negative X.
Good. And that's why we only have one thing to remember, one rule. So we got, let's see, we have 1 over 2 minus x squared. That's going to be a squared. I'm going to write it as 2 squared plus 2 times a times b plus b squared. Is that right so far? Does that look all right?
Looks right to me.
Looks right.
Groovy. And now let's make it look prettier, because that's what math is about. 2 squared is
4.
And 2 times 2 is also 4, times negative x will give us
Negative 4x.
beautiful. And then negative x squared,
Is that just X?
perfect. So we always get 3 terms when we square a binomial, and that's why I'm emphasizing it. So here we had, I get my g back. We had g of 1 over 2 minus x, and this was all squared. Oh, heck, I don't know what I'm doing. Okay, but that's okay. And so we've got 3 times, and we've got 3 times this fraction. So 3 will go in the numerator. And then we've got 4 minus 4x plus x squared. So do g composed with f and f composed with g look the same?
No.
No.
Not even close, which is really cool. Sometimes a function and another function have the same compositions, in which case they're called inverses. Sometimes a function is its own inverse, and that's kind of groovy, but we'll see all that stuff in a little bit. I want y'all to play with the try this 7. And today, let's really, really work on talking. So can everybody see it?
Yes.
Yes, ma'am.
Yes.
Okay, I'm gonna go away, which all I mean by that is I'm gonna mute and turn off my video, but I'm not leaving. So I will hear you or not hear you if you're not talking. So please talk. That's the way that we learn. Bye.
Hello.
Hello.
Is everyone doing all right this morning?
Yeah, I'm doing well.
Same. Okay. Let's see. What do we have here? Gotta sign in, guys.
Yeah, let me do that real quick.
Is it raining on your side, guys?
Yeah, it's raining for me.
It's been going crazy since last night.
Oh yeah. All right. So what do we have here? Wait, I forgot. Is the recording supposed to be still on or so?
Thank you. I just did that. Thank you.
Have a
All right,
Never
Yeah.
mind.
Pierce.
So I was gonna ask, I understand how you get 6 over x minus 1, but
Yes.
how do you get the plus 2 over 1 times x minus 1 over x minus 1?
So we had plus 2,
Okay.
and then 2 is the same as 2 over 1. But what I
Okay.
need in order to combine these terms, in order to combine these 2 terms, I need the same denominator.
Okay.
So 1 times x minus 1 will give me x minus 1. That's no big deal. But anything I do to the denominator, I have to do to the numerator as well, so I'm not changing the whole problem. And that's why we get 2x minus 2 here
Okay.
over x minus
Thank
1.
you.
You're welcome. All right. So let's look at one-to-one functions and inverse functions. A function is one-to-one if any 2 elements in the range, which is in the let's just do a little photo. If we have domain and range, and we've got, let's call them A and B over here. If A and B are different in the range, they needed to be different in the domain. But most of the time, the way that we do this is we say, if A equals B in the range, then the inverse mapping, whatever sent them there. So then f of, let's call it x1. If f of x1 is A and f of x2 is B, this is f, and A and B are the same, then x1 and x2 have to be the same. And let's look at a couple of examples just very quickly, because this idea is super important. So if we had this function, f of x is equal to x squared. And pick a perfect square, any perfect square, not counting 0.
9.
4.
Not 9. Let's go with 9, because that was first. So 9 definitely lives in the range. So let's say if f of A equals f of B equals 9, does that imply that A equals B? So let's see. In other words, are there 2 different ways to get to 9, or is there only one way? So let's see. What is one obvious way to get to 9 if we're using x squared?
3.
Yeah,
3.
A equals 3 works. Is there any other number we can square and get to 9?
I don't
No.
think so.
We're not square rooting, we're squaring though.
Negative
3?
3?
There you go. So B equals -3 also works. Because -3 times -3 is 9. And that's why x squared all by itself is not 1-to-1. And we can see this visually using the horizontal line test. So here's x squared. And you can see that you can draw a horizontal line and cut that more than once. So what we're going to do, and we're going to do this a whole lot in trig, is restrict the domain of this function so that it is 1-to-1. Well, if I had to cut this domain in half, what would be an obvious place to cut it?
Straight down the y-axis.
Yes, absolutely. So if the domain of f is defined to be 0 to infinity, then we've gotten rid of this arm and we are 1-to-1. Then f of x equals x squared is 1-to-1. And most of the time in writing, in print, you see O-N-E to O-N-E, but when you're taking notes, it's much easier to write 1-1. Another way to think of one-to-one is one question gives only one answer. So let's go back here. Any questions? Okay, so the only kinds of functions that can be undone are functions that are one-to-one. If we have a one-to-one function, that means that each x in the domain hits the range one time in one place because it's a function, and each y in the range is hit by one x in the domain because f is one-to-one. Only functions can be one-to-one. So this is all groovy keen, yes? Where's my light?
Yes.
Oh, sorry, something weird. Sorry. Go away, go away, go away. That's not back either. Let's see. Oh my gosh, I hit the wrong button. Sorry. So this little symbol, this looks like an exponent of -1. This is not an exponent. This is a symbol that we read as the inverse of f, or f inverse. So with numbers and functions, yeah. So if we had x minus 8 to the -1, that would mean 1 over x minus 8, because a negative exponent means a fraction. But if we had f of -1 of x equals this is saying that somewhere there's a function and its inverse is 1 over x minus 8. This does not mean x minus 8. We're not flipping it. And in fact, let's go through the steps and find the inverse, find the original function of this 1 over x minus 8. And the steps are here. Well, I guess I didn't list those steps. Okay, that's fine because I'll list them here. So to find an inverse, first you switch f of x for y. Then you switch out all x's and y's. You solve for the new y. You replace that y with f inverse, and then you check. And the way that you check is that a function and its inverse undo each other, which means that f composed with f inverse of x has to be x, and f inverse composed with f of x also has to be x. Whatever one does, the other undoes. I'll type these steps up and put them in the notes just so that you've got them. But let's follow these steps and find the function that whose inverse is 1 over x minus 8. Every page I pull out has already been written on. Oh, here's a good one. Okay. So we're going backwards, which is fine. So instead of F inverse, we want to put Y. So I'm going to write, so start with F inverse of X equals 1 over X minus 8. Now I have Y equals, so this is the first step, Y equals 1 over X minus 8. The second step is to switch X's and Y's. So how do I do that? What do I write down here?
X equals 1 over y minus 8.
Beautiful. Now the third step is to solve for the new Y. And I put it in quotes here because it wasn't Y before. So we want to solve for this Y. Well, this is another little plug for doing extra algebra. How do you solve an equation where variables are in a denominator? What's a technique, a good technique?
The butterfly
Multiply by both
method.
sides.
I think we're agreeing. So yeah, multiply through by the LCD. So here there's just one denominator, but yes, you can think of this as X over 1, and we're going to multiply X times Y minus 8 and 1 times 1. But we're solving for Y. Well, first we've got to multiply through. We can't have parentheses if we can't have the thing we're looking for in parentheses. So remind me how to distribute the X.
Yx minus 8x.
Beautiful. And this is linear in that the thing we're looking for, the Y, it has the first exponent. So that means I want everything that isn't Y on the opposite side.
So can we factor an x out of that?
We don't want to factor the X out. We want to move everything that doesn't have a Y in it to the other side.
So add
So minus or add the 8x.
Yes. Okay, so we've got Yx equals 1 plus 8x. And now, how do we solve for Y?
Divide by x.
Very good. So we get that Y is equal to 1 plus 8x over x. And since we started with F inverse, this new baby is F. And always rational functions, functions that have x's in numerator and denominator, but especially in the denominator, will have rational functions for inverses. I'm going to do one direction and I want y'all to do the other. So let's do, let's see, let's let f of x be red. And g of x, or not g of x, f inverse, the one we started with. And let's compose one direction. Do y'all have a choice, or do you want me to choose which way? Okay, I'll choose. So let's do f inverse composed with f of x. And that means we've got F inverse of 1 plus 8x over x So I'm going to write down the formula for F inverse. And instead of x, I'm going to put in this mess. So far, so groovy.
Yep.
Now, this is a complex fraction because it's got fractions inside a fraction. The most useful way, I think, to simplify a complex fraction is to identify the inside denominator. Well, here, the inside denominator is x. I want to multiply numerator and denominator by that x, that inside denominator. So we've got in the numerator, I've got 1 times x, so that's just going to be x. In the denominator here, I've got 1 plus 8x over x times x. Let's look at that separately. I have 1 plus 8x over x times x. What can those x's do? These x's.
Cancel out.
Cancel out.
Yes. Yes, yes. So now, because we've multiplied x times this fraction, we just have 1 plus 8x and then we've got minus, and what is 8 times x?
8x.
Good. Okay, well, we can't stop. We need to see if we get to x. That was our goal. In the numerator, we just have x, nothing for that. Can we do any simplification in the denominator?
Yeah, you can simplify x, 8x, and then minus 8x. That would just cancel out to make 0.
Excellent. So what are we left with in the denominator?
You're just left with 1
Beautiful. And x over 1,
x.
yay. I want y'all to carefully to do this same process. With f of f inverse. And I'm going to give you the 2 functions again.
I have a question.
Yeah,
So during the process of doing the inverse, right?
yes.
Why would you multiply x with y minus 8 instead of dividing the x?
What, are we at this step?
The one below it. The third.
Okay, so why would we? Can you repeat your question?
Why would you multiply x to y minus 8 instead of dividing it on both sides?
Because we're looking for y. Oh, okay. So if we divided both sides, let's just look at that. That's actually a very good question. So we've got x times y minus 8 equals 1. let's go ahead and do that. Let's divide both sides by x, and we get y minus 8 equals 1 over x. And then to solve for y,
Add 8 to both sides.
add 8, so we have 1 over x plus 8 plus y. But now we have to get a common, excuse me, a common denominator and combine the fractions. So we have to write 8 as 8 over 1. The denominator that we're looking for is x, so we have to multiply 8 over 1 by x over x. Not that much extra work, and we're still going to end up with 1 plus 8x over x. So Ralph, did you ask that question? I didn't see who asked.
Yeah.
Does that make sense?
Yes,
That
ma'am.
you can do that method. That is correct. Correct algebra, correct result. You just have to keep going though until you get to one fraction.
I see.
So we
Okay,
don't.
Thank you very much.
You're welcome. In general, having two terms as an inverse is fine, but not when the variable is in a denominator. When the variable is in a denominator, we want those two terms to be one term, one fraction. Okay, thank you. That was an excellent question. And I'm writing down, oh yes, 1 plus 8x over x. I want y'all to do the steps that we just did to show that f of f inverse of x equals x. We did it just now with, where did we do it? Let me find it. While you get started, I'll find the work that we just did. But I want y'all to start on this now. And I'm going to pause the recording. Okay, I just wanted to show you so that you have it in your notes. So f of f inverse of x, we're going to put f inverse in for all the x's that were in the f formula. So we have 1 plus 8 times 1 over x plus 8 minus 8, all over 1 over x minus 8. And just like y'all said, the inside denominator, the thing that makes this a complex fraction, is x minus 8. So that's what we multiply by. And that means we're going to have x minus 8 times 1 and x minus 8 times 8 over x minus 8. But there the x minus 8 cancel, and we're left with 8. And then we have 1 over x minus 8 times x minus 8. And there again, the x minus 8 cancel, and we're left with 1. And what can we do here? I have 1 times x minus 8 plus 8.
Add the 8 to the negative 8.
Yes, and we're left with
X over 1, which is the same as x.
yay. Okay. Brilliant. Let's see how long it takes me to find where we were. We're going to skip a few of these examples and try this is only because we kind of went past that. So I do want you to go ahead and play with this. On the try this 8, you have f of x is equal to 3x minus 2. G of x is equal to x plus 2 over 3. And I want you to show that they are inverse functions by finding both ways composition. And we're going to skip example 9 and example 9 and try this 9. So the only try this that you need to do on page 2 is the try this 8. If you have one function given, so say you've got say you have this function. Okay, say we've got that. And we would like to draw the inverse of it. So here's f. Oops, right now it's not a one-to-one function. Let's cut it off right here. So I was just going to ask, is f a one-to-one function?
What am I looking at to know that answer? I'm sorry.
Oh, that's okay. So first of all, to see if it's a function, we want to make sure it passes the vertical line test. And to see if it's one-to-one, we want to see if it passes the horizontal line test. And that's why I had to erase part of the graph that I had already drawn. So if you take that part out, do you see that even though we've got a sort of comparable point, it's not defined at 3 on the right-hand side, only on the left-hand side. So does this pass the horizontal line test?
Yes, it does.
Okay, so that means it is a function and it's one-to-one. So this is a one-to-one function. And
So in
that
order to
means
do one-to-one function, you just need to pass the vertical and horizontal line test.
that's exactly right.
Okay.
Exactly right. And a one-to-one function is the only kind of function that has an inverse. That means f has an inverse. And there's a way that we can use the graph of a one-to-one function to sketch its inverse, even if we don't know the name of that inverse. So let's look at this. I want to do a little bit of a prettier picture of f. Yeah. Okay. In order to draw f inverse, I'm going to write down the coordinates of all the points I'm given. So what is the coordinate for this point on the y-axis?
0, comma 1.
Beautiful. And the point on the x-axis?
1,
1,
comma
0.
0.
And we've got one more point given.
3, comma 1.
And let's assume that the slope of this line is 1, so that at 4, what would our point be?
4, comma 2.
Very good. Okay, so those are all points on F. To sketch F inverse, all we have to do is switch. So instead of 0, 1, we want a 1, 0. Instead of 1, 0, we want a 0, 1. That's kind of boring. But here it gets more fun. Instead of 3, 1, we want
1, 3.
1, 3. Let's see, 1, 1, 2, 3. And instead of 4, 2, we want
2, 4.
2, 4. All right, let's see. Well, the first part shows us that the inverse of this little bitty section is itself. That's kind of cool. And then was the function defined at 3, 1?
No.
Okay, so I needed to make that an open. And then what did the function do as it went through 4, 2?
Continued on forever.
That's right. So we're going to do the same thing, but with 2, 4. So this purple is the inverse. The blue is F. And now I'll show you the prettier picture. If we have a function, here the function is in blue. All you do is switch the order of each of the coordinates to get a coordinate on F inverse. So you switch the order, you get a point on the F inverse. And then the line that goes right through the middle of quadrant 1 and quadrant 3, y equals x, is the line of symmetry between F and F inverse. And even on my meh drawing, let's see if we can see. Does it look like if I fold this meh graph along this line, y equals x, that these two little sections will meet?
Yes.
And does this in
Yes.
fact meet with itself?
Mm.
Excellent. So this is a property that we're going to use, property of inverses, to sketch what the inverse functions for the trig functions look like before we know their names. So we already talked about x squared, y equals x squared. Is y equals x squared 1 to 1? And I did not say before, but this is the same question as if I switch x and y, is x equals y squared a function? So there's x equals y squared. Is that a function?
No, it fails the
No.
vertical line test.
That's right. And that's why the horizontal line test tells you whether or not something can be, has an inverse, because it has to be flippable. So what can we do to this graph of y equals x squared so that we can flip it, and so that when we flip it, it doesn't fail the vertical line test?
We can make it go, we can flip it across the x-axis.
I'm not sure. I'm not quite sure what you mean.
How about like flip it
Vertically,
upside down
yeah.
instead of having the parabola
So like it this.
facing upwards, face
Yeah.
downwards.
So if we had it facing down and we flipped it sideways, would we not still have this? Except it'd be in this direction.
Yes. Isn't the fact that it's squared going to keep it as a parabola anyway?
Yes, yes. So we have to cut it in half.
Okay.
We have to cut out the part that makes it not 1 to 1.
Mm-hmm.
So what is one way to cut it? We talked about this earlier.
Limiting the domain.
Yes, we want to restrict the domain. Let's
Right.
just strict. So where here, domain restriction, where should we do that?
We would instead of
At 0, 0.
Yeah, 0, 0 from point 0, 0.
Excellent. So if we did that, that is the same as on the flip side, that's the same as saying we're only looking at positive and 0 y's. We're not looking at that negative part. So if we had a graph, let's see. Oh, I do have a black. Okay. I was just lamenting that I didn't, and I do. So if we have okay, so here we've got y equals x squared, but we're only putting the right-hand side of it. And if, okay, first let's go ahead and label these points. So what is the coordinate of the beginning?
0,
1,
0.
1.
And here? This
1,
point,
1,
beautiful, and here.
4, 4.
2, comma
Almost.
4.
Because it's 2 squared is 4. Okay. And now let's flip. 0, 0 flips to,
0, 0.
0.
okay, and 1, 1,
1, 1.
and 2, 4.
4, 2.
And now it's kind of possible to see. Even if I didn't know the name of this inverse function, I can see that, I can see what it looks like, what its behavior is.
That's the square root of x, right?
That's right. Very good. Beautiful. Okay, I want y'all to play the same game. Actually, I'm going to give you a different function than I have. So the one I was going to give you was cube root and the other cube root. And you can go ahead and do that, but I want to give you something more fun.
These problems that you're going over, are these, we have access to this? Is this in our book that we're supposed to be looking in?
This is review. So this is
Oh, okay.
not in our book.
Okay.
But starting with the right angle trigonometry, it
Mhm.
will be, yes.
Okay.
Okay. So take this function. Is this a one-to-one function?
Yes.
1-to-1.
Oh, no, it's not.
Okay. So right now it doesn't have an inverse that is a function. I want y'all to play with it and figure out where you can cut, and it doesn't have to be half, but where you can cut the domain so that you can flip it and get a function. You want to do this all together?
Sure, I guess. we
Yeah.
can.
Okay, so, but I'm gonna not know what to do. Is that all right?
Yeah, sure.
Okay, so can this little section between -1 and 1, can that stay?
I think so, yes.
All right.
Yeah.
Should we, what is causing the problem here?
The parabola.
Okay.
Mhm.
Can we choose which part of the parabola to keep?
Can
Yes.
decide. Yeah, we can decide.
Yeah. So which side do y'all want to keep? Completely up to y'all.
The positive side.
Well, they're both positive.
They're both positive, but I think the better choice can be from domain of 2 all the way to 4. We can cut that out, leave 1 to 2. I think that should be the best option. Yeah.
So
From there,
make
yeah,
this our
something like
restricted
that.
domain. So we're going to say, let the domain of F be, it's an open here. So -1 to 0. And then it's an open here at +1. And we're going up to 2. Is that right?
Yeah, that looks right.
We can do that, yes.
All right. Now, let's write down the coordinates of each of the points that are left, each of the end points. So this -1, this point on the x-axis is
0, -1.
or like -1, 0.
Oh,
0.
yeah.
Yeah, we're
Writing
defining
down
the
the points that are here, not the inverse of those points.
Yeah.
That's
Pretty
right.
much.
That's right. That's right. We're just looking to write down the points here. So this point on the y-axis is just
0, 1.
and the point that we're not going to include, but that will help us is
1, 1.
and the top.
2, 4.
Beautiful. Okay, so we're going to, what am I going to do with this -1, 0?
Flip. Just flip x and y.
Okay, so let's see, that'll be 0, -1. And this point 1, 1. No, this point 0, 1. I was confusing myself. So 0, 1 is going to become,
1, 0.
and that's filled in. And 1, 1 will become,
1, 1.
and will it still be an open?
Yes.
Yes.
Good. And 2, 4 will become,
4, 2.
beautiful. So let's see. Oh, no. Is that right? It's not beautiful. The
Yeah,
thing is,
but
Sam?
no. Keep going. My bad.
Oh, or no, I was just going to say, the power of this theorem is that you don't have to know what the function is to write an image of its inverse. You can sketch where you want the function to stay defined and what its inverse will look like, even if you don't know the function at all. Page 3, we just have a little bit more.
Just to let you know, we're about to have. It's already 11:18, so we'll have 20 more minutes.
Oh
left.
my goodness! Oh no! And here are the steps. I don't know why I thought that I had missed them. So the steps to find the inverse are here, and we've done that. So, let's take 5 minutes and pick up at our first trig section. Is that all right?
Yes, ma'am.